Hello everyone, happy to see you here. Welcome back to my channel. Hi, Mathematics. Today we have a great relaxing question: t cubed minus t squared equal to 18. We need to solve this equation for t, so if you have your solution, your answer, if you're interested in that, you can also write your solution in the comments below and then we will check your answer. So it will be really interesting. So let's start. First of all, let's write this 18 on the left side. This is our first step. Of course, the relative ways how can we solve this cubic equation, but I'm going to show you this one. So t cubed minus t squared minus 18 and equal to 0. This is our first step. Secondly, instead of this 18, let's write 27 minus 9. So let's do it. So a lot of students might be asking why 27 minus 9. So right now let's wait a few seconds and you will see. So t cubed minus t squared, and as I said before, instead of 18 we write 27 minus 9, okay, equal to 0. Right now let's open parentheses. We have negative sign, so we need to change this one to the opposite one. So let's do it. So we have t cubed minus t squared minus 27 and plus 9. Of course, we can do this instantly without any of these lines, but right here I'm going to show you how can we solve this question step by step. Maybe a lot of students here, so that's why I do this step by step. And right now let's look at this question from a different angle. These two elements, these two expressions, t cubed and t squared. Okay, let's try to find out how can we express this 27 and this 9, and why? Why do I choose this 27 and 9? Because 27 can be written as 3 cubed. Yeah, we can express this also as a cube, and 9 can be written as 3 square, and it's also really great because we have absolutely the same base. So let's use these expressions, 3 cubed and 3 square. So instead of this 27 we write 3 cubed. So let's do it. So t cubed minus t square minus 3 cubed, and plus, instead of 9 we write 3 square. So 3 square. And that's why I choose 27 minus 9, not like 20 minus 2, 30 minus 12. I choose 27 and 9 because right here we can express this as a cube and as a square. And why we can group this t cubed, 3 cubed, and t square and 3 square. So let's do this. Like, we can easily see this question from a different angle, and that's why we group cubes and group squares. So let's start, for example, with the cubes. First of all, we have t cubed minus 3 cubed. So t cubed minus 3 cubed. This is our first step. Second step, we have minus t squared minus 3 square. T squared minus 3 square. A lot of students might be asking why right here negative, right here positive, because of parentheses. This negative sign will change this minus to plus, and we have absolutely the same thing, okay, equal to 0. So I really hope you understand my solution until this moment. This is not the hard steps. I really hope you understand it. We just change this 18 and we just express this as a cubes and we group it, okay. I really hope you understand it. If you still have any question, write a question in the comments below. What are we gonna do next? Next, we're gonna scan this question. We're going to see this question from a different angle. What do we have right here? Difference of cubes. What do we have right here? Difference of squares. And let's remember this formula from school. Okay, so first of all, a cube minus b cube. Let's start, for example, with this formula. A cube minus b cube equal to a minus b. Yeah, a minus b. And in parentheses, we have a square plus ab and plus b square. Okay, really great. Right now, difference of squares. I think everyone knows about this formula, difference of squares, but maybe in case like I just want to write it. So a square minus b square. Okay, so equal to a minus b, a plus b. Okay, really great. And right now, this formula, difference of cubes, we're gonna apply right here, and this difference of squares we're gonna apply right here. So let's see. Okay, first of all, I'm gonna start with the difference of two cubes. So we have t minus 3, and in another parenthesis we have t square plus 3t, and plus 9. This is our formula difference of cubes. We're gonna apply it in terms of this expression. Okay, then I think minus t minus 3, t plus 3. This is maybe easier for us, yeah, t minus 3 and t plus 3, plus 3. Okay, we expand this formula, we expand these expressions in terms of our formula. What we're gonna do next, of course, we just need to look at this question from a different angle, because we don't have any formulas. We just have t minus 3 right here and t minus 3 at this place. So basically we can easily factor it. Yeah, we have absolutely the same expression, so why not? We can easily factor this expression. So we have t minus 3, we factor it. And in another parenthesis, what do we have? We have this parenthesis from first expression, so we just write it t squared plus 3t and plus 9. This is our first expression. And we have minus from here, and from this expression, from this mix, we have t plus 3. Okay, so t plus 3. T plus 3. And big parenthesis equal to 0. Okay, and right now we can't simplify this more. T minus 3, we'll leave it like that. Right here we can simplify it. We can actually get rid of these parentheses because we have every of this expression are positive. And right here we just need to change this sign to the opposite one because we have a negative right here. Okay, so let's do it. So first expression without any changes, so t minus 3. And in the second expression we just actually get rid of this parenthesis, so t squared plus 3t plus 9 minus t and minus 3 equal to 0. Okay, let's simplify it, our last step. So we have t minus 3 in the beginning. What do we have right here? T squared. What about t? We have 3t minus t, so we have plus 2t, and 9 minus 3, we have 6, so plus 6 equal to 0. So we can easily be proud of ourselves that we solved this question. We factor it. First of all, we factor it. We haven't solved it yet, but we factor it. We have two parentheses, and a product of two parentheses equal to 0 when the first parenthesis equal to 0. Okay, when the first parenthesis, for example, our first branch, let's write it as a first branch. So t minus 3 is equal to 0. Or the second parenthesis, so we're gonna write it as a second branch. So we have t squared plus 2t and plus 6 is equal to 0. Okay, we have two branches, and right now let's solve it. First of all, instantly we can solve this first branch, t minus 3, our linear function, t minus 3 equal to 0. So t first is equal to 3. So this is our first root for our question. Yeah. Second, this is our quadratic equation. Of course, this is up to you. A lot of ways how can we solve it, but I'm going to show you the basic method. Maybe a lot of students here, so that's why I use the classic method. So a equal to 1, b equal to 2, and c equal to 6. Yeah, our basic method of coefficients. Let's start with discriminant, for example. Our b squared minus 4ac. Okay, equal to, so we have b squared, we have 2 squared minus 4 times 1 times 6, so equal to, as a result, what do we have? 4 minus 24. So our discriminant is equal to, so from here we have minus 20, I guess. Yeah, we have minus 20. And our discriminant is less than 0. And a lot of students might be thinking, okay, right here we don't have roots, but we have a cubic equation. So in terms of fundamental theorem of algebra, we have 3 roots in total. And that's why this branch is also really important, because right here we can solve this question for a complex root. So that's why let's use our formulas. So t second and t third equal to minus b plus minus square root of discriminant and all over to a. Okay, and right now let's apply this discriminant right here. Let's find our complex roots. Let's see what will happen. So minus b minus 2 plus minus square root of minus 20 and all over 2 times a, 2 times 2 times 1. Let's simplify this. First of all, this minus 20, square root of minus 20, we can express in a different way. So let's do it in a new line. So we have minus 2 plus minus square root of minus 20. How can we write it? And just remember that we have square root sign. So maybe we can use, for example, 4 and 5. Let's do it. So we have minus 1 times 4 and times 5. Why I choose 4? Because we can actually find square root of 4. We can actually use, for example, 10 times 2, but you can't find square roots. We can't find the exact value of square root, and in terms of table cases, it's great to use 4. Okay, so we're gonna divide it by 2, equal to, right now, there's like a really interesting property every time I read this property, and I really hope you understand it, so that we have, when we have like a lot of expressions with multiplication sign, of course I can write it, but every time I write it, and I really hope you learned it, you already learned it, but this is our property, a times b times c equal to square root of a times square root of b and times square root of c, and it can be like a lot of expressions. So that's why we can split it. Yeah, we can write it as -2 plus minus square root of -1 times square root of 4 and times square root of 5 all over 2. Right now, square root of 4 equal to 2. This is our imaginary unit. This is our I in terms of complex numbers. So we have -2 plus minus 2i square root of 5, or doesn't matter, whatever order you select, like 2i square root of 5, yeah, and all over 2. And our final step, a lot of students, a lot of teachers prefer like splitting this expression by real part and imaginary part. So that's why a lot of students use this expression -2 over 2, so they divide our numerator by 2 and our numerator by 2. Yeah, it looks like that. Yeah, 2i square root of 5 over 2, and that's why we're gonna cancel a lot of these 2's from here. So we have -1. Yeah, our answer -1 plus minus I square root of 5. Yeah, -1 plus minus I square root of 5. Yeah, it looks like this is our answer. These are our complex roots. So let's write our final answer. Let's gather all the roots together. For example, let's do it right here. So our answer so t first equal to 3, t second, let's do with the plus sign, so -1 plus I square root of 5, and our t third equal to -1 minus I square root of 5. And this is our answer. We have right here two complex roots. These are our two complex roots, because we have I, and this one real number root. This is our answer. And finally, let's check real quick our real number root, and maybe this is our big question, because a lot of students may be asking, or maybe arguing with each other, why do we solve this question like that? Because we can solve it instantly. Yeah, when we have this question like t cubed minus t squared equal to 18. Yeah, a lot of students, let me just split it like that. Yeah, a lot of students might be saying, okay, t equal to 1, there's no root, t equal to 2 doesn't work, t equal to 3, yeah, we have 27 minus 9, yeah, because then we have 3 cubed minus 3 squared equal to 18, and this is a correct expression, because 27 minus 9 equal to 18. And a lot of students might be saying, why do we need this? Why do we need to solve this question like that? Why do we need this in other branch? We have t equal to 3. I can solve this instantly without any problems. And here's my quick tip to you, for you, because there's like the thing which is called like fundamental theorem of algebra. Okay, I'm going to show you. I'm going to say you this quick trick briefly for a few seconds. Right here we have, for example, t equal to 3 is the highest power. Yeah, in terms of fundamental theorem of algebra, when you have 3 as a power, at the highest power, it means that you will have 3 roots in total. If you don't understand this, for example, look at this quadratic equation. Okay, the highest power is 2. So in terms of this theorem of algebra, we have 2 roots in total, and everyone knows about it. We have t second and t first and t second. Yeah, in our case we have 2 and 3, but this is after first. Yeah, we need to add 1 to this index. Yeah, so we have 2 roots. When we have linear function t minus 3 equal to 0, we have only 1 root, and this is our cubic function. So 100% you will have 3 roots in total. You don't know how many real number roots, how many complex, but it tells us how many roots we will get from here. Okay, 3 right here, 3 is the highest power, 3 roots in total. If you have, for example, t to the power 4 and you solve this question with 1 real number root, maybe this is a great solution, but you forget about 3 complex roots. You know, this is extremely tricky moment, and a lot of students should understand it. This is extremely important part of math, and that's why this inspection method, it's not a good method, because of course this is not a good method for you and for your teacher, because when you solve this question like that, this is not a good way to solve it. And if you look like closely, you just forget about this theorem. If you look closely at this question, for example, this is not a hard question. This is not the hard question at all, because right here we just express it like that. We just need, all you need, just these 2 formulas. then basic calculations, basic algebra, just factor something, just add something. This is not like derivatives, integral or something. Yeah, so my quick recommendation, just learn this equation and everything will be great, because this is very informative equation. We have formulas, we have a factoring, we have a lot of things. We have a complex root. So if you have a problems with this equation, my quick recommendation to pause this video and try to solve this question on your own, or for example go for a walk and then just go back and try to solve this question. Yeah, you know, a lot of things from my perspective. Maybe these things are helpful for you, maybe not. This also up to you, but my quick recommendation, this question is extremely great for everyone to practice your algebra skill. This is not a hard question with different things, a classic cubic equation. So that's why it's extremely important to learn how to solve this question nowadays. Okay. So thank you everyone for your time. See you in the next videos. Have a great day. Also write your thoughts. What do you think about it? What do you think about this type of question? What do you prefer on my channel? So write everything. I will read, and of course I will help you with your question, with your assumptions. What do you think about it? And yeah, see you in the next videos and have a great day. Take care of yourself.